This week, we're going to be talking about load calculations. There's a lot of details, a lot of information that is needed to do that. So we're going to go ahead, we're going to discuss that. I'm going to show you how to perform load calculation, and then you're going to do it on your own home. So let's go ahead and get started here. So first thing we're going to need is a tape measure, and we're going to discuss how to properly read a tape measure. There are 12 inches to 1 foot. For the sake of this lesson, we're going to make sure that we round up to the nearest foot. It's better to be a little bit oversized than it is to be undersized for proper measurements. If we go ahead and we look at the tape measure here, you'll see that we have increments of a 32nd, a 16th, an eighth, a quarter, half, 3/4, so forth. So most tape measures, they're going to come with 16ths built into them. They may not have this 1/32 line in there. For me personally, I don't like it. I just know that in between this line right here and the 16th is going to be a 32nd, and I can purposely mark that out if need be. Otherwise, we have an eighth, and just remember your simple mathematics. If we combine an eighth with another eighth, that gives us 2/8. We divide by 2, which ends up giving us a quarter. And that's just the way that this tape measure works. We're going to keep adding the eighths and until we get to a divisible number, and then we go ahead, we divide, and we get these values here. So it should be eighths, quarters, halves. That's really the designation that we're going to have. So then we have square footage. Square footage is the measurement of an area's size expressed as the number of square feet it contains calculated by multiplying length by width. So real simple, we will go ahead, we will get the value of one side of the room, we'll get the value of another side of the wall there. In this case, we have 20 on one side and we have 12 on the other. We multiply 20 by 12, and that gives us 240 square feet for that space. Real simple. We can calculate multiple rooms. We can then all add them up to get the total square footage for that space. Another value that we need to know is ceiling height. In this example, we have 2 different ceiling heights. In most rooms, you're going to have just a rectangular box or box shape. Here, we've got a little bit of a knee wall and maybe a cathedral type ceiling. So what we want to do is average out what the ceiling height is if it's not just a standard height. So in this example, we would take 7 foot, we would add 5 foot to it, and that gives us 12. And because we do have the 2 values together, we would divide both values to get an average. And so the average for that room would be 6 feet. So it's not the most precise measurement for load calculations, but it's going to get you pretty darn close when you guys are doing this at your home. We then have windows. We have single pane, double pane, and triple pane. If you're able to tell how many panes you have in your window, that's going to be important because we're going to use that value to input that into the software or the sheet here in a little bit. Most homes generally are going to be the double pane. And as far as calculating square foot, very similar to a room. We will measure our height, we'll measure our width, and that gives us our total square foot for that window. Insulation is important because we will have insulation in our walls, we will have it in our ceilings, so forth. We're not going to dive into how much insulation we have, what are the different features or benefits, or how do we really figure out how much insulation we have in the space. It's really just simple values that we're going to give you just to give you an understanding of how to perform this. For walls, we're going to use a default setting of an R13, and for the ceilings, we will use an R30 value. You may have had more insulation that was added into the attic space. I'm not going to make you crawl in there, but for the sake of argument, we're going to just say, hey, R13 for walls, R30 for ceilings. So now that we understand the different values, how to get them, we can go ahead and we can fill in this sheet. So we have this AccuSize heating and cooling home analysis. There's a lot of different factors here that we're going to go through and just discuss so that way you're fully capable of doing this on your own. So let's go ahead and get started. So we'll start over here on the cooling load heat gain 95-degree day. 95 degrees, what that means is that when we design our equipment, we're designing it for the hottest day of the year. It just so happens in the Chicagoland area, it gets to about 95 degrees. It's not always 95. It may be less than that. I'm not going to go into great specifics on it, but just understand that we're sizing equipment to be able to run down to and maintain 75 degrees in the space when it's 95 degrees outside. On the heating side, just because there is a greater temperature difference, we are going to design for a 0 degree day while we maintain 70 degrees in that space. So you'll notice later on that the cooling load is going to be substantially less than the heating load. So we're going to need much more heating power for our home to maintain our temperature than we do cooling. All right, so over here to the left, this is some of the software that I use from time to time, and I've got our home drawn out. So you will do the same thing. So at the bottom of this sheet, there is a grid. Make sure you go ahead and you draw out your entire home. What you may need to do, depending on the type of home that you have, the characteristics of it, you may have to do room by room in order to get the square footage of that space. However you do it, that's perfectly fine. You can do it as one big dimension. You can do it multiple rooms. We'll go ahead and we'll cover that. Real simply, you can build out a small little room just like this, connect it to another room like this, and now we have two rooms side by side. Both are 11 feet in width, right? And that gives us a final remaining space of 12 feet. So we could add all three values together, or we just know that we're going to have 34 feet. Completely up to you on how you want to do this, but it's really important to understand these values. Okay, so let's go ahead and get started here on the north side of the home. I have my little designation up here that shows that this part of the home is the north side of the home. We're going to focus first on the window sizes. I have 4 windows that are located right here with these small little rectangulars, and they are 3 feet wide roughly and by 5 foot tall. So if we have 4 windows, that would equate to 3 times 5, which gives me 15. Multiply that by 4, that gives me 60. So in this box, I will go ahead and type 60. And we're going to multiply that by 21, and that gives me a value of 1260. All right, so that is my heat gain here for the first set of boxes. All right, we will then continue on down and keep completing the left, the left side, the right side, which would be the east, the west, the south. That gives me values throughout. Okay, so I'll let you complete all of that. And then we need to go ahead and we need to look at the values of our doors. First off, what type of door do we have? Is it a wood door? Is it a wood with a storm door? Or is it a insulated metal door? And yet again, we will take the square footage of that door, right? And we will put that value in here. So if we had a 3 foot by, let's just say, 7 foot door, gives me a value of 21. I will multiply that times 6 because that is the number that they give you, and that gives me 126 over here. Next, we need to go ahead and we need to look at our wall perimeter. We've measured out our entire home, right? We have the values that we require, and we're going to add up all the values. So in this case, we've got our 34 feet starting on the north wall plus our 22. Then we have our 6 plus our 8 plus our 6 plus 15 plus 22. That gives us a perimeter of 113 feet. So we will fill in 113 feet. We will say that the ceiling height is 8. We'll go back to our calculator, multiply by 8. That gives us 904 feet minus the glass that we will include. If we just go back to my value here, we'll just say it's 60, but you're going to be incorporating different values. And so now all of a sudden we're going to have a different value. So now we have 904 minus the value that I just put in, and so that gives us 844 square feet for our space. Now we have our 844. We will multiply that by 3. and that gives us a value of 2532. Remember, R13 is what we are using for our walls. Okay, then we will come over to next to our ceiling. We will use an R value of R30 for our ceiling, and what our dimensions were again. We will use our handy dandy calculator, and we will multiply 34 times 22, right? And then we did add the value of the 6 times the 8, which is the 48, which gives us 796. So we have 796. We multiply that by 1.6, and that gives us 1274. We're just going to keep it easy. We're going to just round up to our values. So we're going to just round up from the 0.6 and make it 1274. And I will fill in this value here. Then we will continue on, so forth. And then we would do the same thing for our square feet of our floor. And then we would just put it into the category. Well, we may have either no insulation, we would have carpet, maybe a floor on a slab. So floor on slab would be the you have no basement. If we do have maybe a basement area, maybe there's some insulation up there, we can put it in this category. But most places, most homes in our area are going to be either carpeted or have no insulation. So you can just put the value in there, right? And so here we'll just keep that same value, probably with the 796, right? That's the square footage of our ceiling. So the floor area is probably going to be the same, and then we will multiply that by 2, which we get 1592. Then we have our home square footage. All right, in this case, the whole home, yet again, is the same square footage as the ceiling and the as the flooring. So real simple, we will just add 796 in that category, and then we will just take 796, multiply that by 3, gives us 2388. And then we want to add the number of people that we have in here. Usually it's one person per bedroom. However, some people, have multiple people in a room sharing that space. So just add up however many people you have in that home that stay there, or at a bare minimum, make sure that it's at least one person, 4 bedrooms. So in this example, we'll just use the number 4. We'll multiply 4 times 530, and we will have 2120. A kitchen and bath allowance, that's automatically calculated, and then all you have to do is add up all these different values together to get your total amount. So we'll have 1260 plus 126 plus 2532 plus 1274 plus 1592 plus 388, and then we have the 2120 and 1250. All right. Now, these numbers are not very accurate because we didn't do all the other windows and so forth. Now that we have the values that we require, our subtotal is 6474, we can use that. So we have the subtotal BTUs an hour, and we're going to multiply that by 0.09, and that gives us 583. We'll then take our subtotal again, 6474, and we will multiply that by 1.3, and that gives us a value of 8417, and we will add the 8417 plus 583 to our subtotal values, which will give us a size of 15,474, and that is the BTU requirement that we require for cooling for that space. The smallest system that we're going to find as far as a unitary size is going to be 18,000 BTUs. And so we would put an 18,000 BTU system in. We want to be relatively close to the value that we get. All right. The heating side is going to be very similar to what we just did. Now, the difference being here on the heating side is we do have some glass patio doors, patio windows. So if we have any sliding doors going out into a patio area, we'll make sure that we incorporate those. If you do have sliding glass windows or doors, over here on the left side, make sure you just include them as a window. The heating side, they actually do have it separated between the two. Coming down to the insulation, insulation is we're just going to use this 3.5. 3.5 is going to equate to that R13 value, unless you do have a masonry or a brick or a cinder block wall. If you're not sure, just default to this frame here. Okay. Otherwise, if you have masonry, we can use the masonry values. The ceiling is the same. Square footage of floor over crawl space. Okay. So if we have a crawl space, or if we have a basement, we would use one of these different values. So just like the cooling side, our ceiling aspect is pretty similar. All right, we're just going to use the R30 value when it comes to the ceiling. This is the part that it may get a little bit tricky. You just have to know whether you have a basement, whether your home is on a slab or on a crawl space. A slab basically means that your home has no basement whatsoever. It's a piece of concrete. All your ductwork is just built into the concrete itself. A crawl space, that's a very small area for somebody to crawl down into, usually on their hands and knees. Not a lot of space, not meant really for storage, it's more for mechanical means. And then a basement, I'm sure everybody's aware what a basement is. You have stairs that lead you down there. You may have your washer, your dryer, your mechanical equipment, so forth. So we can use these different values so depending on what type of home you have, you would choose either floor over crawl space, floor over basement, or a perimeter slab floor. Infiltration ventilation, we would just put the square footage in, multiply that by 4.9, gives us our value, and then yet again fill in the same thing that we did on the other side with our subtotal, our losses. All right, and then most importantly, we need to know what type of furnace we have, whether it's an 80% or a 90%. If you have a boiler system, don't worry about that. Pick a value. Make sure that you incorporate whichever type of value you have as far as the boiler is concerned, whether it's an 80 or 90%er. And this would give you your total BTU heat needed for that space. All right. So hopefully that answers all the questions regarding the load calculation. If you have any questions, be sure to email me and I'll answer them in a timely manner. Otherwise, I'm curious to see what numbers you guys come up with.